Yeah.
Another example, of course, is Thomas Kuhn. Now, if it wasn't enough and bad enough for the scientists to be told that, the uncertainty principle and quantum theory and so on, along comes an American historian of science, Thomas Kuhn, and he basically anthropologizes scientific belief and said, you have held to the view that what science does is it progresses by better science. You have the old vision of the world, the pre-Galilean vision of the universe, and then Galileo comes along, and then someone else comes along. And it's better in each case. And what he basically does is very disruptive, because he says these are thought systems. They are paradigms, in his famous word. They are meta-level models of the world, which are not, they don't come in because they are intellectually better, but for often political reasons. The old people who espouse the old systems die off. The young people need to make a career, and they come in and say, that was all rubbish. Here's my better version. It may not be much better, but it's espoused. And so it goes on. So basically, science progresses through a set of stages of ideological change, one replacing the next. Now, as I've said elsewhere, this is not a new idea for Kuhn. It's in Adam Smith and his work on his essay on astronomy, that basically Newton replaces the previous system, and then Einstein replaces Newton, and someone will replace Einstein, and someone, he says that's how it's been from the Greeks onwards. So he's talking about scientific paradigms. But of course, if you start doing that, you make science much more subjective. And it's, again, influenced by world views and other pressures. Okay, so that's
Yeah.
another.
Yeah. And of course, there's more extreme. There's Feyerabend, wasn't there? And Gellner got into lots of arguments with Feyerabend, who again thought that
With Feynman, did you say?
Feyerabend, Paul Feyerabend,
Yeah.
I think, yeah, and his arguments about witchcraft being just as good as physics, depending on what you wanted to do with it.
Yeah.
Um,
Well, I wouldn't be as extreme as that, but I mean, basically, they are thought systems. We have science; they have Buddhism. You could argue something like that.
yeah.
So another thread, these are all disconnected and there's no logical sequence to them, is something that you talked about in one of your interviews, which is probabilistic or Bayesian mathematics, which is a form of mathematics developed in the later, in the 20th century. And basically, it's the basis of modern computer searching, which is that things are not right or wrong, they're more or less probable. So when you search for something, it's the best match, and then the next best match, and so on. When you change the question a bit, you get other answers. So probabilistic theories, which don't just go in mathematics, but then spread out. So we live in a world of probabilist, better and less good, but not absolutely correct and absolutely wrong. So that's another thread in the argument. Okay.
Yep.
The next thread is the difference between laws and tendencies. This is one of the important developments in my thoughts, because much of my education, I've talked about this elsewhere, so I'll only be brief, but basically I was taught that science works by laws. In other words, if A, then B. If you define the preconditions of a phenomena, and that's how laboratories work. They say, let's assemble all the preconditions for why we should produce that result. and then the result will occur. So, but of course that method unfortunately is again pretty suspect. I mean, a famous experiment in the 17th century recalled in an account is of the Royal Society doing an experiment to prove that flies didn't come from human sweat, which was a popular view. So they enclosed a scientist in a greenhouse and shut it all up, and then the sun shone and he started to sweat, and hey, lo and behold, a whole lot of flies were there. Somehow crept in. So this proved that the theory was wrong and that there were flies where, and they did the same with unicorns' horns, which you could, a spider couldn't cross a unicorn's horn, so they got some what they thought were unicorn's horns, obviously something else, and made a circle of it, put a spider there, and it stuck outside the unicorn's horn, and so it proved that theory. So, you know, you can do things with scientific theories, but basically, I was brought up with the idea that if A, then B, that's how physics proves things. Now, I was taught that that's fine for physics, bio, and chemistry, but for the art subjects, it doesn't work. You can never specify the preconditions of anything, and as a result, every event is unique. And I was taught at Oxford as a historian and later as an anthropologist that history and anthropology are art subjects in which you cannot make generalizations. This was a big theme of Evans Pritchard's work. Nothing is universally true. Anthropology has not come up with a single generalization. They've been looking for something, but always you can find counterexamples. You can never say universally people believe in God. Universally, the incest taboo, there is an incest taboo. Everything you can find exceptions to, and therefore there are no laws in anthropology, and likewise in history. History repeats itself in a way, but only roughly. So I was taught history and anthropology are basically novel-like. I mean, you're writing a good story, as they say nowadays, a narrative. But they weren't any truer than anything else. They were just better done. So historical fiction of the best kind is no really worse or better than good history. It's just another way of telling stories about the past or other countries. Now, at the end, when I came to write letters to Lily, I found this a very sad thought that I had not discovered anything. There were no laws. I couldn't tell Lily anything because I couldn't say if this, then that. So, but by chance, I came across the idea that actually in the art subjects, there is an intermediary level of pattern, which is the tendency. It is highly likely or probable that, as I gave her the example, it's very probable that the fish and chip van will come to our village on a Wednesday evening. Now, I can't guarantee it, and it may not come, but you know, from observation of past fish and chip vans visiting the village, that is the case. And lo and behold, when it comes, Lily says, well, you were right. And of course, all our lives are like that. It's Sunday morning, I must be talking to Richard, etc. Once you have that, you then you realize that tendencies are what all disciplines, including sciences, are talking about. That's what probabilistic means. So that the only difference is that along a continuum of probabilistic and likely tendency, as you move from very soft subjects like poetry to quantum, to physics, the tendency becomes higher. It's more likely that your physical laws will operate than your, and there's some
in a way, actually, just inject, in a way, then poetry is more difficult than physics.
Well, yeah. I mean, you know, I've talked to a number of people who do, hard sciences, biology, and who also dabble in arts and things, and say, of course, the arts are much more difficult because you can eliminate all sorts of things in science and concentrate down the problem. But there you're dealing with many, many more variables, much more difficult to be a great musician, for example, or a great painter or a great writer than it is to be a great scientist. They all open